Now we're going to make our final map of Moletown, and as we always know, everything reacts in mole ratios. And anytime you're comparing the amount of one substance to the amount of another substance, you need to use moles. And that's because every atom, so an atom of one element, is going to have a different mass than an atom of another element. So in order to compare apples and apples, or the amount of particles, we have to use moles. So this step happens every time. You use a ratio from the balanced chemical equation comparing what you're looking for versus what you already know about. Now, outside of that, in order to get to moles, there's a whole bunch of different ways to do that now. We have ways to do it for gases, for pure solids, liquids or gases, or from an aqueous solution. So, the first one we learned about was going from grams to moles. When I say grams, you say moles. Now, in order to do that, you multiply by 1 mole over the number of grams per mole of that substance, or essentially dividing by the molar mass. So that'll get you from grams of one substance to the number of moles. If we were given a gas solution, or just a gas, sorry, not a solution, if it's at STP, it's simple. You just divide by 22.4 liters per mole. So that would get us to moles. And then if we weren't at STP, then we'd have to use the ideal gas law, or Pivnert, rearrange it for N, which represents the number of moles, and you'd be given a pressure, you'd be given a volume, you'd be given a temperature, and the R would be the appropriate gas constant depending on what your units for pressure were. Those would all get us to Moletown. Now, if we have an aqueous solution, we can go from volume and we multiply by the molarity to get to the number of moles. Keeping in mind that if you look at how this would set up from a dimensional analysis perspective, molarity is moles of solute per liter of solution. So when you multiply the liters by the molarity, the liters will cancel out and you'll get to moles. So those are all the ways to get to Moletown. And then you still have to, every time, convert from moles of one substance to moles of what you're looking for. And that can vary in what it is. It doesn't necessarily always have to be the product. You could be trying to figure out how many moles of a reactant you need. But you'd have a moles of something else you know about that would relate to that. So you can relate any substances in a balanced chemical equation by using their coefficients in that part of Moletown. Now that we've made it all the way to our destination, now we have to answer the question. So if the question's asking us for liters of gas, if it's not at STP, we got to rearrange Pivnert to get volume. So we divide moles, gas constant, temperature, by the pressure. If we're at STP, just multiply by 22.4 liters, because that's how much a mole of gas takes up at STP, any gas. And then, if we're looking at solids, liquids, or gases that are pure, we just multiply by the molar mass. And then, if we're looking at solutions, well, we would divide by the molarity, because that would give us liters over moles, and we'd be multiplying that by moles. So, this is the overall map of Moletown.